Hello, and welcome to the Field Guides. I'm Steve, and I'm here with Bill. Good morning, Bill.
Morning, Steve.
What we're going to do today, and over the course of many future episodes, is give you the experience of what it's like to be out in the field, in the woods, and on the trail. Each episode, we pick a natural history topic, research the science on that topic, head out to a natural area, and oh my God, don't keep going forward.
And try to traverse trails that are completely flooded.
Yeah, only one of us is wearing gum leaf boots
That's
right now.
I wear my boots.
So we take you out into the field and share with you everything we learned.
That's right.
At least one of us does that lately. So Bill and I have switched over to taking over responsibility of research every other episode now. So last episode, I talked about timber doodling. And this episode, Bill told me what he's doing, but since he told me, I have completely forgotten. So, Bill, what are we going to talk about today?
So today, it depends on how you pronounce it.
Oh,
so
boy.
It's like the pileated thing.
Okay.
Would you say Myrmecochory or Myrmecochory?
I say Myrmecochory.
Myrmecochory.
So I'm even saying it different than both
That's
of those
right.
things.
You put the Myr in there.
Yeah, Muir, like John Muir. Spelled totally different.
I will say that from what I've heard, when I look at videos or listen to podcasts, it does seem to be Myrmecochory.
Okay.
So that's what we're going to go with today.
Mm-hmm.
And if the listeners out there have a problem with that, well, brace yourselves, because that's the pronunciation we're going to be using.
Yeah, so it is, I think it's Muir as in John Muir, and then cockery as in woodcock. Are we doing another woodcock episode? You know I'm an etymology guy.
It's John Muir.
All right, so...
So we should tell people what that is, though. Because
Yeah.
there's probably listeners out there that don't know what Myrmecochory is. But before we do that, let's talk about where we are, what's around us, give people a picture.
Uh-huh.
All right? And there's a couple things I want to talk about before we get into the meat of the episode.
Yeah.
All right, so where are we?
We are at Nature View Park, and we are actually a stone's throw from where my parents live and where I guess I used to live back 10 years ago when they moved out here.
You sure you want to reveal that to people?
We're in Western New York, guys. So,
So we are in the town of Amherst. I was looking this up before recording today, and Nature View Park is over 1,100 acres. I want to make sure I get that right. It's over 1,200 acres.
Wow.
In the second most populated town in Western New York. So this was set aside through a great grassroots effort. I'll put a link into the episode notes. But this was another project that was guided by our friends at the Western New York Land Conservancy.
Oh, great, yeah.
Yeah, so we just recorded the Downey Harry game episode at one of their locations. This is a land trust that works here in Western New York trying to preserve areas of natural and historical significance. And a bunch of people here got together. I think it was 2006, but it was a great story about locals coming together, preserving this site from development. I mean, over 1,000 acres.
And I do remember that about this park is that it's new, or it's relatively new,
Relatively.
I should say. Yeah.
I had never found myself at this place, so I was pretty excited to see it. But then we pull in today and I asked Steve, have you been here? And he said, oh yeah, I've been here. It's not that great.
Though I will say we are in a very wet spot right now, which I'm fine with because it's definitely already tick season and they don't like the wetness.
Oh, that's right. So as I said, I'll put in the episode notes information about Nature View Park, but just to give the audience an idea of where we're at, we are about, 20 minutes northeast of Buffalo.
Yeah.
And I actually looked on a map, we're about a half an hour east of Niagara Falls.
Okay, yeah.
Yeah, so we're north of Buffalo, south of Niagara Falls, and to the east. And we are in a beautiful spring woods. Right now it's April 25th? So spring has sprung here in Western New York. We have leaves are just starting to open on the trees. The spring ephemerals are up.
Yeah.
I was out a couple days this week and seen trout lily, seen hepatica, spring beauty.
Yeah, a lot of spring ephemerals.
Yep, I haven't seen any trillium yet, but I know people have been posting it.
Oh, yeah.
So we may run into them today. And that actually is a perfect segue into what we're going to talk about. But
Okay.
I'm not going to jump on that yet because we've gotten some comments about people asking about my health.
Oh,
so I
yeah.
do want to update people because the last time we spoke about it,
Yeah.
I think I told people that I just don't have Lyme disease, or at least the test came back negative for it.
Sure, yeah.
So I did go to a doctor. Have I told you this?
Well, yeah, so I don't ever wonder about your health because I'm a bad friend and I'm not a team player. But you did.
Well,
so
you're a self-absorbed millennial, so.
Yeah. So the fact that we still decide to meet up, that's good enough proof for me. Like, I look at the evidence, we us scientists really sometimes have to measure things indirectly. So Bill wanting to meet up is his way of telling me that he is alive and healthy. So
I'm okay. So I went to a rheumatologist, and they did do a bunch of tests, and he said that at some point last fall, I probably fought off some kind of flu-like syndrome. My body created antibodies that weren't quite a match for what was wrong with me, and they ended up attacking my nervous system.
Oh boy.
And he said, since I'm not a young man anymore, that it's taking my body longer to heal. So I was having tingling in my extremities, some loss of sensation, and he said that I may have a little bit of that for the rest of my life, but that it does seem to be slowly healing and that it doesn't seem to be progressive. So he sent me for some more blood tests, and he told me to give him a call about a week later and that we'd go over them. And I did, and he hasn't gotten back to me yet, and that was 2 weeks ago. So
Probably bad news.
I'm assuming that since he's not getting back to me, that it's good news.
Yeah.
I'm assuming that, but I've been leaving messages and hopefully he'll get back to me. So that's where we're at. But,
Hey man, you never got back to me. I'm really worried.
but I do want to bring up that we have a third person with us today.
Oh yeah.
My daughter is here with us. Violet, say hi.
Hello.
With all this talk about ticks and tick season, which we'll talk about more a little bit later. Violet, can we talk about your tick? Violet's
She's shaking her head.
I bring that up just as an example of this time of year, April, May, it's something to watch out for.
Yeah, and I think a good way to put it is don't be afraid, just be cautious and be
Right.
prepared. Yeah.
Don't be afraid, be aware.
Yeah.
So we've been off this week on spring break, and every time we go out, we come back and we're usually doing tick checks. And I did find a black-legged tick on my dog
Oh,
this week.
yeah.
So we actually gave her a bath after the hike, and I found it crawling along the edge of the tub. So,
Oh wow.
Yeah. So they're out there.
Mm-hmm.
Before we get into it, why don't we do you think we
Yeah.
can get around this puddle here?
Can you even talk while we get around it?
Sure. I can actually walk right through the middle of the puddle.
And I'm going on the outside. Ugh. Oh my God, why did I wear these? Okay.
So Myrmecochory goes along with what we were just saying a moment ago about spring ephemerals. That is one of the group of plants around here that are in a relationship with ants. Ants are spreading their seeds. So,
An enemy?
no. What do you mean?
Hepatica.
Oh, I thought you said an enemy. Ants are not their enemies. No.
Yes. They like those eliosomes, right? On the seeds?
That's right.
Yeah.
So in its most basic sense, Myrmecochory is ants are getting food by picking up and moving plant seeds.
Mhm.
So it's typically seen as a mutualism, but we'll talk more about that. And
Yeah, why would they just grab the seeds and move them? I don't know.
now I do have to give a shout out to Indefensive Plants and our friend Matt. Much of what we're going to be talking about in this episode comes from an interview he did with Dr. Robert Warren,
Oh yeah.
who's based here at Buff State in Western New York. They did an interview on Myrmecochory because Dr. Warren does some research into Myrmecochory ants.
Yes. So that's a seed dispersal. You know what? Is there a word for that? Because I know there's like a pollination syndrome, but is there what do you call that when it's a seed dispersing mechanism? Is there a word for that?
Oh, I don't know.
Yeah, I don't know.
Well, there's two forms that he talked about in that podcast.
Yeah.
One is with granivorous ants that feed on grain and seeds.
Mm-hmm.
These ants, they eat and destroy the seeds, but they don't eat all of them. So they cache them. This is analogous to squirrels and acorns, or blue jays and acorns.
Right. So they stash them to eat all of them, and then they don't eat all of them.
Right, so they end up getting dispersed, and
Yeah.
whichever ones they don't find, they sprout. We're going to be focusing on today eliosome-based
Okay.
Myrmecochory.
Eliosomes are a snack.
That's right. So this is a special appendage that is on a seed, and as far as we can tell, it's meant to attract carnivorous or scavenging ants. The way it's supposed to work is they pick up the seed with the eliosome attached, and later on at some point they're going to detach the eliosome, eat the eliosome, and discard the seed.
Do you know what I think of when I think of eliosomes?
What?
I think of wasabi peas. Where like you're not eating them for the pea. You know what I mean? Like the pea isn't like the tasty part. The wasabi's the tasty part. And the pea just gets eaten along the way. But I guess that's where the thing falls apart, is that the wasabi's the good part, so that's the eliosome, the thing that the ant wants. And then the seed, that just gets dispersed. But I guess in my example, you're just eating a pea. So
Maybe if you had a dab of wasabi on the pea,
Yeah.
and you had to take both,
right.
you would eat the wasabi and throw it.
And then toss the pea into the ground, and then a pea plant would,
There you
would
go.
grow. There we go. The false analogy comes home.
Now, in this process, the idea is that ants benefit from getting this elaiosome, and then the plants are going to benefit because they're moved away from their parent plant. They're placed safely underground, so that protects them from predators, and it can also protect them from fire and fire-prone areas.
And they're getting underground because they're going into like the ants' tunnels and stuff.
The ants are carrying them into their colony.
Yeah.
And then these ant nests are usually nutrient-rich and moist. Again, from Matt's podcast, Dr. Warren talked about how many of the involved ant species are desiccation intolerant. So
Okay.
they can't stand dryness. So these colonies are often a beneficial habitat for the seeds to germinate in.
Mm-hmm.
Seeds are often taken out of the nest and put into midden piles, which are also often nutrient-dense sites.
Yeah. Oh, why don't you say what a midden is?
You tell me.
Well, I've heard of people using middens to look at like seeds throughout different periods of time. Have you heard about this? There's some research where they find middens that are like deeply buried, and they're like...
Are these wildlife-generated middens or
Yes.
people-generated middens?
Wildlife.
Okay. Paleobotany kind of stuff?
Yes, that's what I'm thinking
Oh,
of.
okay.
Yeah.
Well, that makes sense. So these are just discard piles, basically garbage piles.
Sure.
And ants will discard garbage from their colony. They'll also discard corpses there, sometimes depending on the ant species.
Okay.
And different animals do make midden piles. In an evergreen forest, piles of discarded pieces of cones. Those are squirrel midden piles.
Mm-hmm.
Now, Myrmecochory, if you've never heard of it, you might be surprised to know that globally, Myrmecochory is very common. And it's been most studied in North America, but it's the least common here.
Okay.
Now, traditionally, it was thought that there were about a dozen ant species involved here in North America, but more recently, it's thought that there's actually very few ants that are effective seed dispersers, and that in most systems, it's probably just one or two particular species that are the effective dispersers of seeds in that system. So here in eastern North America, in our deciduous forests, the most common ants you're going to find belong to the genus Aphenogaster, the ones that are related to Myrmecochory. And there's one common species, Aphenogaster rudis, that will come up throughout today's episode.
Okay.
So the funny thing though is I looked this up on iNaturalist, and there's actually very few Aphenogaster sightings in all of the Northeast. But how many people out there are taking pictures of ants? And
Yeah, right. And did you say, let's say if we were to look at this ant, is it like a typical black ant that you would...
The ones,
think of?
I looked at a couple different species. One was kind of reddish, one was more blackish.
Okay.
But yeah, there's nothing that I could see as a
As a non-ant person?
as a non-ant geek. that said,
Myrmecology?
"Whoa!"
Or what would it be? Do you know someone who studies ants?
Entomologist.
Generally, I guess. Yeah. Okay.
No, I don't know.
Yeah.
I'll email E.O. Wilson. See what he says.
Uh-huh.
But yeah, so they didn't have like, a second head or something where I could say, oh, that's an Aphenogaster ant.
Yeah.
So if we come across any ants today, unless they're carrying, a seed from a trout lily or something, which shouldn't be out right now.
Sure.
But let's get into a little bit of the background. As I said, this is a widespread phenomenon. There was actually a study in 2010. It looked at the evolutionary history of Myrmecochory, and it involves over 11,000 plant species in 77 different families. And then there's 71 species of ants that are involved.
Wow.
This process has become so widespread that it independently evolved in plants somewhere between 100 and 147 times.
Holy cow.
Yep.
Okay.
So this is a wonderful example of what kind of evolution?
Oh,
Come on.
convergent evolution.
There you go.
There we go.
Convergent evolution.
Yeah. Sorry, I didn't prepare for this episode.
So producing an elaiosome, this thing that's attractive to insects, it's assumed that it has relatively low cost and high benefit. So it's a great example, a dramatic example of convergent evolution. But let's get into what elaiosomes are. You seem to know that word. You said it before even I did today.
Uh-huh.
So what's the main component? Like, what's in there that the ants want? Do you know?
Is it fatty?
It is.
Yes. Okay.
Yeah, very good. So they're usually lipid and or protein rich.
Okay.
It attracts the ant to carry away the diaspore.
Well, the diaspore is just the seed. Well, it's the thing that's attached to the seed that helps it get places. So a diaspore on a maple seed would be that wing thing.
So
Yeah.
in the literature that I was looking at,
The samara. Sorry, guys. I forgot all my vocabulary
No.
all of a sudden.
it's
You
the
know,
helicopter.
the wing thing, a.k.a. the helicopter, a.k.a. the samara,
I
a.k.a.
can't believe I let winged thing go by. I wasn't even going to call you out on that. So the definition that I read said the diaspore is the dispersal unit of the seed and the elaiosome.
Right, so like a dandelion, that would be the wispy, I can't even remember what part of the plant
what
that
is it called? The pappus.
Yeah, the pappus, but I think the pappus is just like a weird altered version of sepals or something.
Oh, probably.
They're real weird, yeah. Like asters are a crazy family in terms of their morphology, so.
All right. Can you get this in the background?
Yeah. Are those wood frogs? No, what type of frog?
I think those might be chorus
I'm
frogs.
so bad at the frog calls. I worked at it like 2 years ago, and then all of it has gone away.
So, folks, hopefully you caught that. You picked that up on the mic,
Yep.
right?
Mhm.
We're going to look that up. They sound like spring peepers, but it's not that clear
Yeah,
note.
there was like a roughness to it.
Right. So
Yeah.
we are going to look that up. I'm going to put it in the episode notes.
That's the one that sounds like a comb that we just heard, right?
Well, you're thinking of in the woodcock episode, I said the peent kind of sounded like a comb.
I'm thinking of I've heard a certain frog call be compared to a comb as well.
Oh, okay.
And that one I think reminded me of it. Like one
did?
of those beard combs. Yeah. Yeah.
The
At
hipster
least that's
comb.
what I use them for. I don't know.
All right, the elaiosome theoretically provides nutritional rewards. Now, it's primarily to the ant broods in the nest. Typically, ants, when they detach the elaiosome, they're not eating them themselves. They're going to bring them back to the nest and feed the young with that.
They're team players, yeah.
Now, all the elaisomes, they vary in physical and chemical structure. So you can't think that an elaiosome on a hepatica is going to be the same as the elaiosome on a trout lily.
Yeah.
And so they vary from plant to plant and place to place, but basically you can think of it as a dead insect signature. So there's lipids in there we mentioned, so fatty acids.
And you know those fat insects that everyone likes.
Well.
I'm thinking of the ones from The Lion King. I mean, I
God.
kind of said it as a joke, but then I thought back and I'm like, those looked real fat from that Hakuna Matata scene.
We can't use Disney as our yardstick, though. So oleic acid is one of these fatty acids, and this particular one in nature, it often induces what is known as corpse-carrying behavior.
Oh, interesting.
Yeah, and this is where ants carry their dead to a midden pile, which we just mentioned. This acid is also similar. Let's see if you know what this is. I did not know before researching this
Yeah,
episode.
but I'm a genius, so let's see.
So oleic acid is also similar to insects' hemolymph.
Yeah, I don't know.
Well,
So it has something to do with blood. and
Right.
Okay.
so I had to look that up. That's the fluid equivalent to blood in most invertebrates.
Okay.
And that also incites a prey-carrying behavior among carnivorous ants. So they like sense this and they're like, I gotta grab this and get this out of here.
Bring out your dead.
Very good. The morphology of these guys, the elaisomes, along with all the ants involved, determines movement success. So as an example of this was one line in the main paper that I used. Now, I want to be upfront. The main paper I used was actually not technically a published study.
Oh.
It was
Did
actually,
it say unpublished? Or-
well, it was not listed as part of a journal. This was a dissertation someone did
Oh.
under the direction of a researcher.
Okay.
It was an overview of Myrmecochory, kind of where we're at and what's missing in present research.
Okay.
It's really looking at whether it's a mutualism or not, and that's going to be the heart of this episode. But I used this paper as my main research document, but then it led me to lots of other research as well.
Can I be honest with you for a moment?
Yeah.
The reason I don't read dissertations is that they are way longer than your average paper.
You're right, but this one wasn't.
Oh, really? It was the short one?
This was about 20 pages long.
Nice. Okay. That's typical, maybe a little bit more than average.
So I was able to look at it, kind of give it a quick overview and say, you know what, I think this will provide a good jumping off point. Because this, folks, this is a huge field, and I kept trying to decide, should I boil it down to just looking at one species of plant and one species of ant? But I really found that the question of, is it really a mutualism, was the most interesting to me, and hopefully to the folks out there. But I said all that because there was one line in this paper that said, basically the shape and the size, the morphology of these seeds, and then the morphology of the ants determines the success of moving the seeds. Like, well, what does that mean? So I looked up the paper, and what they're talking about, it's pretty basic. They're saying, well, ants are different shapes and sizes. Seeds are different shapes and sizes. So if you have a giant seed and a tiny little ant, that ant's not going to be so successful at moving it, right?
Yeah.
So there was one study from 2007 that they referenced. They looked at 4 different plants interacting with 8 different ant species. So within those 8 species of ants, their mandibular gap, so the gap between their mandibles, varied widely. The low end for the smallest species was 0.3 millimeters.
Okay.
So tiny. The high end for the largest species was 2.1 millimeters.
So tiny. No, but way bigger than the 0.3.
Right.
Yeah.
While those differences may not seem massive to us, if you're the size of an ant, that's a big difference. They went on to say that removal by small and medium-sized workers is limited by seed weight. Small ants remove small seeds, and bigger ants are capable of moving a greater range of sizes. So it all depends on the plants that are around. Now, let's talk about the benefits to ants.
Okay.
Supposedly Myrmecochories. If it's a mutualism, right? We all learned when we started learning about ecology that a mutualism is when both species involved derive a benefit. Quintessential examples of this include, I'm going to put you on the spot.
Oh, well, you know what? One of the ones that we talked about in the sap episode was there's a microorganism that lives in the gut of hemipterans. It helps them deal with their excess sugar problem.
Right.
So those gut microbes were benefiting by getting a snack, and the hemipteran are benefiting from not dying because they have a way too high osmotic potential in their stomach. So that would suck all the water out of them.
Couldn't you have just said pollination?
Oh. Well, I try to do callbacks to previous episodes, Bill. All right, so
I know. No,
and that was, and I loved that episode. I thought that was a fun one.
And you can also think of really any kind of animal-mediated seed dispersal. Animal eats a fruit, it gets some nutrition, and it's going to spread that seed somewhere else.
Acorns and jays, another episode.
Another shout out. So the putative benefits that ants are supposed to derive are dietary in nature. They get these eliosomes. But the fitness consequences, so the benefits to them of engaging in this practice, really have not been well explored. We should say that within an ant colony, there are different castes, of course, and they have different needs, energetically speaking. So ant workers, they need quick sugar sources, carbs, to sustain their more active roles. And so food sources other than eliosomes could be more preferential for them. Now, there's been some recent studies that have suggested that feeding on eliosomes may not always be of benefit to ants. So there was one in 2013 that looked at Trillium diaspores, and it said these attracted more seed dispersers with higher oleic acid content, but then more ant worker death was reported compared to ants that dispersed diaspores of other Myrmecochores.
Interesting. So this would make it so they're being pretty selective with who they want. Like, let's say if we were imagining that there was some evolution going on, that this actually was some type of mutualism, maybe the ants are, the ants collecting those seeds is kind of like a mistake, sort of, in evolution.
Right.
So, because they don't really benefit from it as much, unless that cost-benefit analysis, like, it's still fine for the ants and they still get by just as well, or...
There's a lot of ants, right?
Yeah, sure. Yeah.
And you might be thinking out there, folks in the audience, that, well, hang on. How can you know that those two events were connected, right? And that particular study, I didn't read that study, so I can't say for sure, but they did say that study shows a detrimental effect to the ants, and it corroborates other work. There was another study in 2013, an isotopic study that showed pupa production in Aphenogaster was not enhanced by supplementation of eliosomes. And then a little farther back in 2012, another isotopic study.
Melanogaster?
Aphenogaster.
Oh, sorry. I was like, why are they looking at flies all of a sudden?
No.
Sorry. This is me half listening.
And then in 2012, there was another study that showed nutrition from eliosome benefits ants more when insect prey is not abundant. Now, there's one researcher, Beatty, who was active back in the 80s, who did a lot of work with Myrmecochory and is often referenced in more recent studies. And he emphasized that the food needed to support ants is dependent on the state of the colony. So that plays a role as well. Just like with most of the things that we look at in this podcast, it's complex.
Yeah.
And you can't say it always happens this way or it only happens this other way. It's going to depend on the plants involved and the ants involved and a lot of factors.
Right.
But one thing that is clear is that the direct benefits to ants from Myrmecochory remains unsolved. But we are going to get into this more a little later on. But right now I want to talk about the benefits to plants. But before we do that, let's walk because Violet's getting a little anxious.
Yeah, and maybe while we walk, I want to bring something up. So very often on episodes, I sound smarter than I actually am because I had the time to do the research and I can write notes and all these other things. But for this episode, obviously I didn't, and this is my question. For something to truly be
A mutualism?
Does it have to be like vital to their, not quite survival, but their ability to, well, yeah, why don't we say survival? So they both like kind of depend on each other in a way and they both benefit from each other. Or can it just be a facultative type of thing? What are your thoughts on that?
Well, it's funny because I think I have an answer based on something I stumbled across this morning related to this research for this episode, and that's there are obligate mutualisms.
Okay.
So think of a fig and a fig wasp.
Okay, yes.
That plant and that insect, they cannot survive without each other.
Yeah, and that's a pollination syndrome. The fig depends on the wasp going inside of its weird flower structure,
Right.
where it's like kind of like a ball and all the flowers are on the inside of the ball. So
Right.
the wasp goes inside, does the pollination thing. Sometimes the wasp comes out, sometimes it doesn't. But that's where it gives birth to its young.
But you can have mutualisms that aren't obligate. So think of a bear eating wild black cherries.
Okay.
That's a mutualism where the bear's going to benefit from eating the fruit. The wild black cherry seeds are going to be spread, but you can have black bears living in places without wild black cherries.
Yeah, right.
So that wouldn't be an obligate one.
So they benefit from each other while they interact with each other, but it's not necessarily a thing that has to happen in every case.
Right. So my question, coming off of your question now, is do some of the plants or all of the plants that are involved in Myrmecochory, they need to have those ants around? And that's the question I don't know.
Yeah.
So I didn't find that out in my research. At least it didn't come up. I wasn't looking to answer that specific question. But if I can find an answer, I'll put it in the episode notes.
And let me tell you what that answer would look like, I think. So I think you'd have an allelopathic effect where the parent plant wouldn't allow germination of seeds immediately underneath it.
And what is, tell people, they're probably going to get it from context, but just in case, what is
Right.
allelopathic?
Allelopathy is when the plant releases certain secondary metabolites into the soil that it's like a defense,
Right.
essentially. It's something that's not important to the primary survival of the plant, but it's like a secondary thing that they do just to get an edge, you know?
So black walnuts.
Yeah.
They have
So
jaglonia in their leaves and husks, so black walnut trees aren't going to grow up under the parent plant.
and what about Solidago canadensis? Doesn't it have something? Another?
I don't know.
I could have swore that there was some.
That was our first episode.
Well, either way, you would have to imagine that if that were the case, that a parental plant would stop even its own seeds from germinating directly below. I think that would be really good evidence where it depends on those seeds dispersing instead of just dropping right underneath the parent plant.
Okay, but when you think of spring ephemerals, don't you see a lot of them growing close together? Are those all clonal?
But they might not be allelopathic. I'm just saying that this would be an obvious or a potentially, you would have a greater chance of it being true where Myrmecochory was something that was actually needed for that species to survive.
Okay.
And you know what, that was literally off the top of my head. There could be some good reasons to reject that, my idea, but I think that might be some evidence anyway. It could be a bit of evidence.
I like how it sounds. Although I do like rejecting your ideas too.
Yeah, I mean, and hey, we do a lot of that in science. We reject constantly, so.
All right, so I was trying to talk about benefits to plants. So,
Permission granted.
thank you. So as far as we know, plant seeds, they get dispersed away from their parent. They gain protection from predators and fire. They gain a more suitable microsite for establishment and growth. Now, we can say that each of these does have substantial backing in the literature.
Okay.
All right? So there's lots of evidence that says, yes, these things do happen. But there's a but.
Oh, yeah.
The advantage is that they're not consistent across all systems. They lack explicit mention and research into specific treatment, physical or chemical, of the seeds. We'll talk more about that.
Mm-hmm.
And it rarely incorporates multiple participants, including multiple ant species and involvement of other taxa, like microbes.
Okay.
And again, we're going to get into that more. So basically saying things are more complicated than it's often presented.
Okay.
So originally, it was thought that the plants developed this strategy as a result of ant food not being abundant in the early spring. So there's not a lot of food. So if I make this attractive elizome and attach it to my seed, ants are going to come for it. But recent research really hasn't upheld that hypothesis. A better theory might be that ants prefer big seeds and that the spring ephemerals, at least here in our northeastern woods or our eastern woods, are competing with each other. If you're seriously interested in this topic and want to learn more, there is a thorough review. There's a book that came out in 2007 called The Ecology and Evolution of Ant-Plant Interactions.
Oh, wow, yeah.
I was able to read just some of this book, but it's a book that I definitely want to read to find out more about it. It goes into it a lot more in depth. But the picture-perfect idea of Myrmecochory has rarely been documented in its entirety, although some instances do come close.
Wow.
Are you picking that up?
Yeah, but it's fine.
So let's talk about the inconsistencies in the mutualism.
Okay.
And I should say that there is a lot of debate out there. It's kind of one of those things that Myrmecochory has been upheld as this beautiful example of mutualism.
Mm-hmm.
And when you get researchers saying, well, maybe it's not really mutualism, there's pushback.
Yeah.
People get upset.
I was going to say, do you think it's emotional pushback?
I'm going to be talking about some of the holes that people are seeing in this idea as it being a mutualism.
And then the real question is, are they holes or are they just glass windows? It's really stable, but no.
Well, they're like hallways. But you'll see.
Uh-huh.
So in the mutualism ideal, ants are going to gain a food reward via the elizomes while the plants gain all these other benefits. But the growing literature suggests ants may not consistently receive benefits from these elizome-based diets. And I mentioned some of that in those studies earlier on. So in Matt's podcast, Dr. Warren, in his words, he said, at best, it's commensal.
I was going to say, that's commensals where one benefits and the other one. It's kind of neutral, whatever.
Right. It's neutral. Yeah. At worst, he said, it's parasitic. That the plants are harming the ants, and the ants really can't help it. And again, folks, it's going to depend on which ants you're talking about, which plant species, where this is taking place, because it happens in Australia, in South Africa, in Brazil, and it came up in a lot of other places in the world. It takes place in very dry environments, whereas here in North America, it seems to be mostly in our deciduous forests.
Mm-hmm.
So a lot of the research seems to say that the ants don't get a great amount of food benefit, and that maybe the ants have been distracted by these plant seeds, wasting their time on poor food sources when there might be better food sources they could be spending their time on. Dr. Warren referred to a juicy dead spider. Might be better.
Uh-huh.
And there's even some evidence that shows a negative correlation between the number of seeds found in an ant nest and the lipid health of the ants within the nest.
Oh.
So it's like coming into a apartment littered with drugs and alcohol, and the people in there aren't doing so well, right?
Yeah, or a house that's littered with empty milk cartons and everyone everyone has calcium deficiencies.
I don't feel so good. No, we should say that this relationship is correlational. It's not causal. So maybe desperate ant colonies have nothing but those seeds to feed on. Mm-hmm. So it might not be the fault of the seeds.
Right.
But
they're making the best of a bad situation.
Right.
Yeah.
So other considerations that we should be looking at. Benefits from seed burial, that is, seeds being taken into the ant nest, are in some cases detrimental and in many cases ephemeral, which means the benefits aren't sticking around for very long at all.
Mm-hmm.
Benefits from the direct seed treatment, that includes elizome removal, they're overstated. And then ants may involve other taxa into the equation for plant fitness, for helping the plants. So I'm going to look at some specific areas. So we're going to look at seed burial, then elizome removal, and then we're also going to look at other predators and participants in this whole process.
Mm-hmm.
So let's get into seed burial. And we got to say that there's actually very little known about what occurs to ant-dispersed seeds within ant nests. It's led to ant nests being referred to as black boxes. Few studies have followed seed destination in there. So it has been shown that taking the seeds into the nest, it can lower seed depredation from predators. but the location that they're in the nest chamber can void any short-term benefits. Think about it, if they're too far underground, right? There was a 2010 study looking at some ants in French Guiana, and that found that the ants would carry seeds of the plant species anywhere between 14 and 40 centimeters deep within the nest.
Oh, wow.
And so their lysomes would then be consumed by the brood. But at the deepest end of those depths, they were considered way too deep for germination of that specific plant species. Here in North America, the most prominent ant species that it's involved, do you remember the genus?
The Phaenogaster?
Phaenogaster.
Yeah.
They're known to nest in rotting logs and under rocks. Not usually the most hospitable sites for these plants. So it's often seen that seed burial is going to provide seeds with escape from predators or fire, but some studies show that seeds may remain dormant in a seed bank without redispersal, unless they're then taken out of the ant nest.
Yeah.
And the time seeds remain in the nest may be short. In some cases, there is redistribution. Phaenogaster rudis, in one study, redistributed 93% of handled seeds outside the nest. So they took them into their nest, removed the elaiosome, and then brought them out into 1 week and just put them in the leaf litter. So this shows that ant dispersal, at least in some cases, doesn't really provide these long assumed long-term benefits of remaining hidden below ground, or even the longer-term advantage of being deposited in a nutrient-rich site. They just took it in their nest and then kind of throw it back out just onto the leaves.
Do you think those groups, they don't have as deep of nests or something? Or why do you think they're getting rid of the seed?
I have no idea.
Yeah, I wonder.
I don't know. Now, some studies do emphasize that this simple act of redispersal away from the nest can lower the probability of seed predation by just widening the spatial density of seeds. They're just spreading them out a little more, so predators aren't going to eat a whole bunch all at once. But all of this just emphasizes the importance of redistribution of seeds. It really needs to be looked into a lot more. So what's happening with these seeds? Violet? Okay. Don't go too far, all right? So let's talk now about elaiosome removal. There's a number of Myrmecochory plants. I love that. Myrmecochory. Though not all, that have been shown to benefit from removing the elaiosome. So these benefits could include increased probability of seed germination and the hastening of germination. Now, seeds with elaiosomes do have higher predation risk. So if the elaiosome remains attached, there's a higher likelihood that a predator is going to eat it because there's that fat-rich crest there.
Now that's like a wasabi pea.
Yeah.
There we go.
But get this. The vast majority of the work that's been done on the benefits of elaiosome removal, the benefit to the plant, almost all of them have involved experimental removal of elaisomes.
Oh.
So people cutting them off.
So it's not really, it doesn't necessarily reflect what's actually happening.
Right. I mean, you could say, well, what's wrong with that? Well, it's not the same thing.
Yeah, but if we do find out that there's some species that do that, we'll have all the data we need.
So, I mean, to put it bluntly, there's very little info about the specific benefits of the direct handling of these seeds by ants.
But it does make sense, though, that they would remove them.
Sure.
Because that's just a type of negative control, because you're taking away the elaiosome, which is, it's important to know how they would act without that independent variable, so that's definitely an important thing.
I'm not saying that doing this experimentally has no benefit,
but
it's definitely not the same thing as researching what happens when ants do it. Now, this is the cool part, very cool part. We're going to look at other predators and participants. So did you know that recent research, like within the past 10 years, it's been suggested that gastropods may play an even more important role in moving these seeds than ants.
So Bill's talking about snails and slugs.
Right. So there was a 2011 study. Now, I want to read what they wrote here because they can say it better than I can. So they used 105 beech forest sites. So this was in Europe.
Okay.
To test whether Myrmecochory presence, and they're talking about Myrmecochory plant species, and abundance is related to ant or gastropod abundance, and whether experimentally exposed seeds are removed by gastropods. So Myrmecochory's plant cover was positively related to gastropod abundance, but was negatively related to ant abundance. Gastropods were responsible for most seed removal and elaiosome damage, whereas insects and rodents played only minor roles. These gastropod effects on seeds were independent of region or forest management. So they're suggesting that terrestrial gastropods can generally act as seed dispersers of Myrmecochory plants and even substitute Myrmecochory where ants are absent or uncommon.
Wow.
So they eat the whole thing
Mm-hmm.
and then just poop it out later.
And the seeds are viable after that?
Yes.
Oh.
So there was very little damage done.
So they probably, so maybe these species require some like scarification or something to help them germinate. Well, who knows? It would be worth looking into because there are a lot of species that require being digested.
Oh, right.
So
Yeah, sure. But
the elysone would be a nice little trick to ensure that something eats it, right?
yeah, see, I'm not sure because now that you say that, that study that I looked at, the mandibular gap, I wasn't able to read the whole study. It was really dense, but there was one part where they were talking about grooves in seeds, and I don't know if they were talking about grooves that the ants created
Or that were previously there.
Right. Yeah. So I got to look into that more. So there were a couple other studies that I found that talked about gastropods and how they're also helping to spread these plant species as well.
Now, is there a word like Myrmecochory, but for Myrmecochory, sorry, but for gastropods?
Gastrocockery? I don't know.
I don't like the sound of that.
No. All right, so let's talk about small mammals now. Now, these guys are cast as the primary seed predators of Myrmecochory.
Okay.
But they may not be the only source of mortality. And this was part of Matt's podcast, his interview with Dr. Warren, that I found super fascinating. And when I was listening to the episode and he got to this part, I'm like, all right, we got to do something. So think about this. Elysomes likely attract fungi and bacteria that could cause issues with seed survival, right?
Mm-hmm.
So dispersed and even redispersed seeds, they're going to encounter soil microbes during their long period prior to germination because these guys, their seeds are going to get spread and they might be sitting there 6 months before germination happens. But rarely have these pathogenic factors like microbes been considered seed predators of Myrmecochory seeds. And the researcher said this oversight is curious given their ubiquity as seed predators in a number of systems. So, some species of ants have metapleural glands. Do you know about these?
I don't even know what that means.
I had never heard about it. So these are special glands that continuously exude antimicrobial compounds. When you think about ants living in this social system where they're all densely packed together, you have a big potential for
disease. Yeah.
So some types of ants continually exude these compounds, and it's a reason most ants are horrible pollinators because these chemicals kill pollen. And if exposed to these secretions, seeds may have more of a chance to resist the many soil pathogens that could result in reduced health or death for them.
Yeah.
So at least 90% of moist temperature plant death is in the seed to seedling stage due to fungal disease. So Dr. Warren was actually involved in a study in 2018 where they looked at soil that Aphenogaster ants had been active in and antless soil. And the Aphenogaster soil had significantly less phytopathogenic fungi. So fungi that was specifically targeting plants. So escape from predation, it's the typical model is that, oh, these seeds are moved underground so rodents can't get at them. But the escape from predation may have more to do with the seeds just being handled by the ants than previously thought. Isn't that crazy?
Yeah, that's a really, really weird thought.
Right.
That it's like a chemical thing rather than
they're treating
a physical
the seeds.
thing.
Yeah. And I'm sure the ants aren't doing that on purpose.
Yeah.
It's just evolved that way.
Man, this is totally a side topic really quick, but tell me if I'm wrong or right, or maybe if you don't know, but the leafcutter ants, they cut leaves and they carry them back to their home, their colony, and then they put them underground, and they're not eating the leaf, they're eating the fungi that grows on the leaf. Yeah. So I wonder if they either don't have these glands or if they can control it in a way where they can turn it on and off.
Right.
Or it doesn't kill the fungus that they eat.
That
something
fungus
else in their digestion does that, so they can break it down. So they're just not killed by the fungi. So.
I'm just going to guess, and this is a complete guess.
Yeah.
I'm just guessing they don't have the metapleural glands.
Yeah, well, who knows?
I'm just guessing.
It's complicated out there, man.
Is it?
Is it?
Yeah. Okay, is your mind blown yet?
I mean, for sure. There's a number of questions that I have that I will not find out the answer to now. But yes.
All right, so I just have a little bit more left, but before I do that, I think we need to talk about our sponsor for this episode.
Oh, yeah. Gumleaf USA. And I kind of think this is like our second call to action this episode, because I was already very clear that I'm probably ruining my shoes right now because I'm not wearing any boots.
Steve has on these blue sneakers.
By the way, these are incredible shoes. I'm not going to say the brand because they're not sponsoring us, but these are the only shoes I've been buying for the last 10 years.
Well, they're pretty much ruined now.
I'll have to buy another one.
They're almost covered in mud because Steve is not wearing the beautiful rubber boots that I'm wearing.
Yeah, which are also covered in mud, but that's perfectly fine for these boots.
So Gumleaf USA, they offer Wellington-style natural rubber boots for men and women. They're perfect for spring wildflowering, birding, herping, hunting for farm work, or just standing on the sidelines of the soccer field. And I wanted to say, like, in the past month, I've been hogging these boots because we have one pair to share. I've used my boots to wade through a wet lawn alongside my kid on an Easter egg hunt while everyone around us was getting soaked, muddy feet.
And I imagine incredibly unhappy because that's how I am. Even an outdoorsy person does not like getting wet.
And they were all eyeing up my boots with envy. I also use them to search in vernal pools looking for salamanders and amphibian eggs. And most importantly, I've been protecting myself from ticks.
Now, we did have a listener phone in a way. They wrote something on Facebook. Have you noticed any ticks on the boots? That's what I want to know.
I have not. No, but I haven't also been looking.
Right.
But I will say, in all the times I've been out this spring with my daughter and my dog, I found ticks on them, but not on me.
Mm-hmm. You got to get some Gumleaf boots for your dog and Violet.
That's a good idea. So Gumleaf has a factory in Europe, and they've been making these rubber boots there for over 80 years. They're well-designed boots with features found in boots that cost twice as much. They're made from 85% natural rubber, and that's why they can flex over 1 million times without a crack. And competitive brands use between 25 and 50% rubber mixed with plastic and synthetics. So it's likely that if you buy a pair of less expensive boots, you're probably going to have to replace those well before your Gumleaf boots wear out. And with their neoprene cushion liner and Vibram sole, you have comfort, durability, and quality. So check out Gumleaf USA boots, and we'll have a link in the episode notes. And do we have a offer code yet or no?
We don't, but if you're a patron to our podcast, Gumleaf USA is offering free shipping. So as long as you contact Gumleaf before making your order and paying for that shipping at a time, they should be able to help you out with that.
Oh, good.
So let them know that you're a patron of ours, and you should get a good deal out of it.
Yeah. Check them out. All right, let's kind of wrap this up by talking about the shift in approach that needs to happen and questions that are still out there. So despite the benefits of seed burial being kind of ephemeral, inconclusive, and elaiosome removal being inconclusive and not adequately tested, and seeds being subjected to predators besides vertebrates, the importance of ants in Myrmecochory may still be unequivocal. And to better understand the role that they're playing, a shift in approach needs to happen.
All right, let's back up for a second.
Yeah.
I know what unequivocal means.
Yeah.
But I have to admit that I don't like that word because it doesn't sound like what it means.
Okay.
So do you want to say that? What?
So the importance of ants may still be very significant.
Right. Unequivocal means that there's nothing ambiguous about the relationship, like it's happening.
Right.
We know it's happening.
So in order to find that out, we need to know how important is the need to have elaisomes removed quickly. So do you know what arils are?
Can you spell it?
A-R-I-L.
A-R-I-L? No, I cannot think of
So
this.
think of a U.
Okay.
And the seeds in a U, they're
the creepiest seeds. I
Yes.
hate U seeds so much. They almost look like, let's say, olives with the what is it, pimento inside?
Yes.
But instead of being green, they're like almost like a translucent pink,
Right.
with this kind of grayish, brownish.
So it's like
seed
a
inside.
fleshy covering. It's
Yeah.
similar to a fruit, but it's not a fruit.
U fruits are gross looking, I think.
So appendages such as arils and fruits are known to harbor microbes that can influence seed mortality. And fungus culturing ants, like the ones you mentioned, that remove fruit pulp and arils from fallen fruits, they have been shown to significantly increase seed germination probability, presumably by deterring fungal infection. So maybe ants are playing a similar role with these Myrmecochory seeds. More research is needed to test the importance of elaiosome removal by ants and the importance of ant seed dispersal in general. What is the actual series of steps that seeds follow? Historically, we've looked at when the seed and the lysome are brought to the nest and the lysome portion is consumed by the larva. This act of removal has been viewed as the critical step for germination. But other possibilities involving ants treating these seeds have been neglected. It includes possible seed cleaning, right?
Mm-hmm.
So is there double duty happening? And the benefits of this double duty have not been adequately tested. And this relevance of removing the lysome, it could differ for seeds that remain in the nests versus those that are redispersed into middens or just into the leaf litter. So some basic questions that need to be answered. What are the chances that pathogens will kill the seed if left behind by the ants? Are the ants providing anti-pathogenic properties to the seeds when handling them? Do plants benefit more from being left in the nest or moved outside? Are seeds being redispersed in random non-special areas or midden piles, or are they nutrient dense? And what are the specific effects of lysomes being removed by ants rather than experimentally removed by researchers?
Man, nothing like ending an episode with a bunch of questions.
I'm going to end with a statement that I worked hard on.
Okay.
Myrmecochory is not a simple mutualism. It's a beautifully and frustratingly complex range of positive, negative, and possibly neutral interactions between a variety of plants and ant species.
That is nice. It was beautiful.
That's a good sum up. That's all I have.
All right, guys. So I know I usually jump in at this point and thank a bunch of people that mentioned us on their websites and thank their new reviewers and new patrons. I did not do that this time. But even, and I want to say this is a little spoiler for next time, spoiler with the thank yous, Podbean reviewer, we saw you. You're our one and only. So.
On Podbean. Yeah.
So we'll give a mention to everyone who is a new reviewer, new patron, new everything next time.
That's right. And if you want to get in touch with us, you can email us at thefieldguides@gmail.com. Follow us and like us on Facebook. You can tweet at us at FieldGuidesPod and check out our Instagram feed at FieldGuidesPodcast. As always, you can check out any of our episodes on thefieldguidespodcast.com.
And if you like what you hear, we'd be incredibly grateful if you left us a review on iTunes or any other podcatcher. And if you want to support the podcast, you can do so at patreon.com/thefieldguides. Or if you're like me and you can't afford to financially support a podcast, share it with a friend. That's definitely the best way, word of mouth, to spread these podcast episodes around.
So before we sign off, I just want to remind people that they should check out the In Defense of Plants episode, number 166, about Myrmecochory, our inspiration for this episode. You might also want to check out a blog I came across. It's actually called myrmecologicalnews.org, all one word. So that has links to literally hundreds of research articles about Myrmecochory. So check that out. And don't forget, I'm looking down at Steve's feet right now. Get those kids outside. Let them get muddy. Let them get dirty. Let them flip over rocks and turn over logs. Get those kids outside.
Do as Bill says and what he does.
That's right.
Because Violet's with us.
All right, Violet, say goodbye.
Bye.
Bye, guys.
See you next month. The low end for the smallest species was 0.3 millimeters.
Okay.
So tiny. The high end for the largest species was 2.1 millimeters.
So tiny. No, but way bigger than the 0.3.
Right.
Yeah.
Tiny compared. I was going to make some joke about your penis size, but I'm not going to.
Well, now you can, because